Alright, you 11s. So just carrying on exercise 3I, discriminants and inequalities. Let's just have a look at where we left off in yesterday's session, if this works. Okay, cool. And let's see if my pen works. Okay. So an example I gave in class, I said you can have x squared plus 6x minus 4, and I showed you can use a quadratic formula to find out the x-intercepts, which you find as these 2 points in decimals, right? The whole point was in 3i is not about getting the x-intercepts. The question is, how many x-intercepts are you going to get? That's the real thing you're looking for. And in later exercises, so exercise 3J, for example, you're not specifically looking for the x-intercepts anymore. You're actually looking for the number of intersections. And when we get to 3J, I'm going to remind on that point again. So it's the number of intersections. Because if you think about it, x-intercepts is really when the quadratic graph intersects with the straight line y equals 0. That's what you're actually solving for. So let's have a look at well, we talked about if the discriminant was positive, you get two solutions and whatnot. Let me just whoops. Oh, what do I do? I'll go back. Okay. I'm trying to get my pen up. So in class, the last time I left, where I said if it's positive, it makes sense that when you square root the discriminant, if it's a positive, for example 4, you get plus or minus 2. So of course you get two answers. You either plus the answer by 2 or you minus the answer by 2, which is why you get two x-intercepts, which is what has happened over here. Okay, so you see it's plus or minus the answer. It's plus root 13 or minus root 13, which is why you get two different x-intercepts, which is shown on the graph over here. Okay, now what I want you to see specifically is, like I just said, you're actually comparing later in the exercise, discriminant specifically in a quadratic equation, you are looking for the number of times it intersects with another graph. In this case, you're looking at when will this parabola intersect with the straight line y equals 0. This is a straight line, okay, which happens to be your x-axis, which is why we call it the x-intercept or x-axis intercept. But really, you're just looking for a straight line. I mean, for all I know, in exercise 3J, you could be looking at a line like this. It could be a straight line like that. And you're asking, how many intercepts does that have and where is it? In this case, we've got two. We've got 1, 2 intersections. That's what you're actually doing. Exercise 3J is exactly the same thing you've been doing. Instead, this one was y equals 0. That's your line, and this is your equation, x squared plus 6x plus 4. And what you did was you equated them. You said if they were to intersect, then that means they have the same coordinates. They have the same x and y coordinates, which is why you could say if this is y equals x squared plus 6x plus 4, then these two y's, if they intersect, they're going to have the same values, because at these points they have the same coordinates, which is why you can then say 0 equals to x squared plus 6x plus 4, because you're saying that both the y coordinates are the same. You're saying this equation has y equals 0, and this equation has y equals to x squared plus 6x plus 4, and you're equating them. That's what you're actually doing when you let y equal to 0. So there's more to it than just saying y equals 0. Which is why in exercise 3J it becomes really interesting, because you can actually solve for which straight line, and you can actually make it so that you can have a straight line where it touches the curve just once, which talks about discriminant being 0. Remember, this is called the discriminant. That means there's only one intersection or one solution. Or you can also make it such that it doesn't have any solutions at all. So that means your straight line could look something like that and doesn't touch the parabola at all. That's the idea, okay? That's the idea of what 3i, 3j, and 3h is doing. Inequalities, you're putting, 3g, inequalities, you're putting them all together so that you can solve quadratic equation in a more in-depth way. Okay, so let's do a couple examples to get you rolling. Let's say this example here. Okay, I forgot to do the animations for this actually. So if we could just ignore this section for now, okay, we could just ignore that section for now. I just want you to think what the question's asking. Now notice this is saying x squared plus 6x plus m. Now if I just go back a step, see, this was the graph of x squared plus 6x minus 4, and this is what the graph looked like. Okay, this is what the graph looked like. That's your graph. Okay, what I'm asking in the second part is I'm asking what values, if I didn't give you -4, see how this is -4 here, see that's -4. What if I didn't have -4? What if I had -m? So the question is, what value of m will change? Right now it's got 2 x-intercepts. If I change m, when will I actually get a graph that only has one solution or doesn't have any solutions at all? You know, that's what I'm looking for. So that's what this next question is about. This question's saying, what value of m will change this problem? So remember, you're looking for the number of solutions. You want to find out when will the graph cross or whatever, right? Then you're actually just trying to find the number of intercepts there are with the y-axis, because that's what you're looking, I mean the x-axis. You're looking for the x-intercept. So that's what I wrote here. To find the number of solutions, which is your x-intercepts, you gotta let y equal to 0. So that's what I've done. I've let y equal to 0. Okay. Now I've highlighted 6 and m because the discriminant, which we know is b squared minus 4ac, this is your b, that's your c, and a is a value of 1. So I put it into the discriminant formula. This is what it tells me. You see, the thing about this is, because we don't know what m is, it gives me an equation or a function. Okay, it doesn't give me an answer. So normally I'd get an answer of a negative number, 0, or positive. Right now I've got 36 minus 4m. That is an equation of all the possible answers you can get. Notice I wrote here, visualize this. Because what I want you to do is picture this. This is what I'm saying. I'm saying, okay, so you no longer have your y and x axes anymore. You now have a discriminant axis, and you've got an m axis. Okay, so you see how the discriminant replaces your y value and your m replaces your x value. What I'm trying to say here is you're just trying to find the relationship between the number m, this is m, so the number that you choose for m, how that affects your discriminant. Remember, your discriminant, if your discriminant is positive, you get 2 solutions. If your discriminant is equal to 0, you get 1 solution. But if your discriminant is less than 0, you get no solution. So what you're actually looking for is you're looking for what's the relationship. If I chose any number for m, how does that affect my discriminant? Do I get 2, 1, or 0 solutions? Okay. Now you already got the equation. The equation is 36 minus 4m. Technically that's a straight line equation. Gradient of -4 and one intercept at 36. So if I ask you to sketch this graph right now, I can already tell you one intercept at 36. So let's say this is 36 here. Okay, so that's your 36. If I ask you to find your m-intercept, which, you know, this is your discriminant, equals to 36 minus 4m. Okay, And same thing, you want to find your m-intercept or x-intercept, you let y equal to 0, in this case discriminant equal to 0, and this is what I want you to see, 0 equals to 36 minus 4m. Okay, and then if you solve that, that tells me m equals to 9. So 9's over here. I'll put it right there. And so I get this straight line equation. The reason why I need you to interpret this is because you've got to remember something. You've got to remember this is now your y-axis. The discriminant is your y-axis. So you're not talking about y values anymore. You're talking about discriminant. And this is what I want you to see. You are describing this. This is what you're describing. See, all the values, this is your discriminant values. All of this is your discriminant values. Anything above the m-axis of this straight line here, okay, remember this is where m equals 0, the discriminant equals 0, okay. So if I follow the line, if I ask when is it above 0, what I'm asking is this. So you know, remember we talked about inequalities, and then I asked you, what does it mean when we say discriminant larger than 0, okay? What does it mean to say discriminant is larger than 0? I'm just saying when is it above that line 0. See, this is the line 0. When is it above that? Well, according to the graph, I know it is above the line when, see, this is my line, this is when discriminant is greater than 0. Whereas right here, right there, right here, right on the x-axis or on the m-axis, this is where discriminant is equal to 0. So I'm going to just write it down so you can see. This is where discriminant is positive, because just look on the y-axis, okay? And this is where the discriminant is equal to 0. Okay? And then obviously the bottom half, this is where the discriminant is less than 0. Right there. So what does that mean? I told you that the m-intercept currently is 9. So if I chose any number greater than 9 for m, so see, this is m, we were trying to solve for m. I said if you choose anything greater than 9, bigger than 9, not equal to 9, bigger than 9, it should have no solutions. I want to show you that, okay? I'm going to show you that. So let's have a look on GeoGebra. I'm going to put all this on Schoology, okay? So let's have a look. Where's my GeoGebra? Oh, there it is. Okay. So, same thing. See how I've got 1x squared plus 6x. This is on minus 4 right now, yeah? But we said, let's change that m value. I said if it's greater than 9, if I have greater than 9, it should have no solutions. Let's have a look. I'm moving, see, look at it, it's 6.5, I still have 2 solutions. If I move it right to 9, let's go. Right at 9. 9 has exactly 1 solution, which is what we solved before. See, look. See, remember here? We said right at 9, right at the m-intercept. That's what we solved here, yeah? This is what we solved. So when m equals 9, you got a discriminant equal to 0. We said discriminant equal to 0 is 1 solution. Okay, and that's exactly what I got. So, let's say if I chose any number greater than 9 then. So you see, as soon as I hit 9.25, it's no intercepts. You see that? So that discriminant graph that we were describing just now, this graph right here that you see, 36 minus 4m, actually just describes to you what values you can choose to ensure that this graph will have 1, 2, or no solutions. So according to this graph, if you chose any number less than 9, it should have 2 solutions. So let's try that. See, if this number, this is currently plus 13.5. If I change that number to less than 9, so here we go. This is 9. If I, okay, less than 9. See, it's already 2 intercepts. You see how I've got 2 intercepts? 1, 2. If I made it 36 all the way down, still 1, 2. That is your goal. Your goal for exercise 3I is to be able to determine how to find, whoops, how do you get rid of that? I don't know how to put it back. Okay, cool. Your aim is to really just find how many solutions there are. Okay, I'll do another example so you can see. Okay, I'll do another example. So, whoops, what is that? All right, here we go. Same thing, I forgot to put that in animation mode. I'll put it in animation mode before I upload it so you can see. But here we go, same deal again, same deal again. We are now saying we want this equation. So this is a 4x squared plus m minus 4x minus m. Okay, whatever m value you choose, we want to make sure that this is going to be above the graph or below the graph, or has whatever. In this case, it tells you it wants one unique solution or no solutions. Okay, so you only want one x-intercept or you want no x-intercepts. So what values of m should you choose? Now, same deal. In order to find x-intercepts, you gotta let y equal to 0. So that's what I've done. I've let this y value equal to 0, so I've done it there. And again, I've highlighted the coefficients of your constants and x's. So this is your discriminant formula, which is from your quadratic formula inside the square root. I'm going to put b, this is b, so b squared, m minus 4 squared, and then negative 4 times a is currently 4, so times 4, and then times c, which is negative m. Put them all together, and simplified, I get this equation. Okay, so discriminant equals to m squared plus 8m plus 16. What I want you to do is visualize this problem again. So let's visualize this. I'm going to draw this again. Same thing as what we did before. Same thing. So I'm going to do, this is my y-axis, this is my x-axis. I've got discriminant, I've got m. Okay? What I'm trying to find, or I want to see, is what this graph describes. It's going to describe all the possible solutions I can have. That means you now have to draw this quadratic equation. Okay, now there's a bit of a lag, so I'm going to jump to OneNote and try to do this, and hopefully it doesn't lag. So it's m squared plus 8m plus 16. Where's my OneNote? That's my OneNote. Okay, so m squared plus, what was it again? 8m plus 16. 8m plus 16. We want to graph this. We want to know what this graph looks like. So again, goes back to your quadratic skills, and you're meant to be able to factorize. So if I were to factorize this, I know discriminant equals to m, and I know I got to find two numbers that times give you 16, and add or subtract to give you 8, and I know that 4 and 4 will give you 8, and 4 times 4 is 16. So actually this is just m plus 4 all squared. Okay, and I know this is a turning point form, so I already know this tells me left by 4. Doesn't go up or down, and it's a smiley face, so I can already picture the graph. I can say, alright, it goes left by 4, and it's a smiley graph, so let's do a green line so you can see. So this is my parabola. What we need to describe from this, okay, what I want you to do is to interpret what this means. What does this mean? Let's think about it. Right here, right at negative 4, which is the m-intercept, right at negative 4, your discriminant equals 0. Because remember, this is your axis. This is your discriminant axis. It happens to sit on when the discriminant equals 0. So what does that mean? When m equals negative 4, we know we're going to have one x-intercept. Okay? Whereas if you chose any number less than or greater than negative 4, well, the graph will always have a positive discriminant. Because look at it. It never goes down, so there's no way you can ever get no solutions. the only way you're going to get is you're only going to get one solution, which is one x-intercept, or you're going to get two. Doesn't matter what m value you choose. Okay, so that means m could be any value you want right now, and you're only going to get one intercept or just two. Let me prove that to you. Okay, let me show that to you. So I want to create an equation on GeoGebra. I'm going to change this to, what was the equation again? I forgot. It was 4x squared, so I'm going to change this to 4. 1, 2, 3, 4. 4. Well, no. Where is it? 4. Well, no. There we go. 4x squared, yeah? But we want it to be m minus 4 times x and minus m. So what I'm going to do is I want to manipulate this equation so it fits our problem. I'm going to call it now b minus 4. Whoops. B minus 4 times x, and what was it again? Times x and minus, since I called it b, then I'm going to do minus b. Okay? So, now I'm going to manipulate m. So, b right now stands for m. So, that's 4.5. And let's say, so we said if we chose m value, the value of m, we chose it to be 4, you should have 1 intercept, because that's what our calculations told us. The calculation said, calculation said if you have negative 4, you get 1 x-intercept. Let's try that. So if I chose negative 4, let's move it. So I'm moving it down. See how this is negative 2.25? Well, if I now move it down to negative 4, let's have a look. Negative 4. Oh, there we go. And look at the graph. Look at that. It sits exactly on the one axis, or on the x-axis, one solution. So I'm going to zoom in just so you can see. Okay, so look at it. That's sitting on 1. Whereas if I then chose any number left of negative 4, see, you get 2. If you look closely, there's 2 x-intercepts there. Yeah? Or if I chose less than that, still, it's 2 x-intercepts, 2 x-intercepts. You only get 1 or 2. You never ever get none. And that's exactly what our calculation or graph here has shown. And the reason why discriminants become confusing is because a lot of students confuse this. You started off with y equals to 4x squared, and then it was what was it again? It was plus m minus 4x and minus m. So this is your y, and that's your x, right? So you got a quadratic equation, but it depends on the letter m. And then you use the discriminant, and you get this equation. You get m squared plus 8m plus 16. And the reason why students find this confusing is because you are now getting 2 quadratic equations, but they both describe different things. You see, this quadratic equation describes how many solutions this quadratic equation can have. Okay, so that's why it's confusing. I totally understand. Okay, so rewatch this if you need to, but I want you to practice exercise 3I. It's the most important concept, and that's what you're actually doing. I want you to try to understand it. Don't memorize the technique. Try to understand what you're actually doing here. Okay. Notice I label my axes so that I know what I'm actually working for. I'm looking at discriminant when it's positive, when it's equal to 0, when it's negative, and notice that I do know it's my m values and not my x values. Okay, so just reiterating again, this graph that you see right now describes all the possible values that your actual equation, this is your actual equation, the actual quadratic equation can have. You can either have 2 x-intercepts, which currently it does, and as I move this, we calculated in order for it to have one solution as if it was negative 4. So if I go to negative 4 again, there. See, and that's exactly what I got. It's one solution. That's what you're solving for. That's exercise 3I. Okay, so I'm going to go back to this, and these are the questions I want you to do. So it's in your PowerPoint. Do questions 5 to 17. You can skip, the first 4 questions because it just tells you to find the discriminant, and to me, that's pointless. We all know how to plug and play, but what we don't know is how to answer these questions. So for example, question 5, they're also getting you to do the same thing again. Find values of m for which you have no solution, one solution, or two distinct solutions. Okay, you just need to answer when will it have one, when will it have two, when will it have none. Okay, and you answer exactly the same way as we did for 3G, inequalities. Read the intervals, the domain. Okay, so the same deal with this one. Zero equation, x squared minus 4mx plus 20. Okay, you want to know what values of m will ensure you have one, none, or two solutions. Okay, that's your goal. So I want you to do that. Exercise 3I, 5 to 17 for... Yeah, do this for Wednesday tomorrow and then Thursday as well. Okay, coming Friday, then have a look at the next exercise. Once you become proficient at these questions, 5 to 17, take your time. Wednesday, Thursday, take your time to really understand it. Okay, so I really want you to practice that and really understand it. Okay, so that's your 5 to 17. I want you to do all. They're really important. Okay, and I'll do another video for 3J. Alright, watch this, rewatch it if you have to. I'll make a quiz for the weekend as well. When we hit the weekend, I'll do a quiz to ensure that we all understand. Okay, but practice this. Thank you. Should I discard? Yeah, I probably should. How do I stop the video?